Hello. Arinst vector analyzer or antenna analyzer portable small-sided devices apparatus in the frequency range from 1 MHz to 6 GHz. The single-port vector analyzer, it has one high-frequency connector, in that case SMA family. This is a missing port of the devices. The resting high frequency requires our connection to it. This device is signed to measure to matching and characteristic of various high-frequency devices such as antennas, cables, adapters, connectors, filters, attenuators. The name Arinst is derived from the keyword amateur radio instrument, a radio amateur tool. This is not a clone of famous devices, not a devices from Chinese shop. This is devices of Russian decision. It is pleasant to hold in my hands a device that is made in Russia. This device is sold in packing. In the kit is a brief instruction. Full instruction can be downloaded from the link in the description of this video. The kit comes with a mini USB cable for charging the device. The device is autonomous. There is a built-in battery that is charged from a USB connector. There are two USB sockets on the case, full-size and mini. You cannot use this connection at the same time, only in turn. Also, the connectors are used to connect to computer and download software, which is still under construction and testing. When it appears, I will tell you about it. Using this analyzer, you can measure the following parameters: SVR, reflection coefficient, the phase of the reflected signal, impedance, loss in the line, the distance in the cable to the point of the match, heterogeneity, range of walking frequency in the from 1 to 6200 MHz, the number of scanning points up to 1000. The scanning speed is 1000 points per second. Resolution of frequency up 100 MHz in a 100 Hz. Resolution at a frequency about 100 MHz in 10 kHz. The device has 8 buttons and color SD screen with a touchscreen function. The device can be in two states, in the menu or the measurement mode. In the menu we change any setting of the device parameters. In the measurement mode we measure the characteristic of the line connection to the test port. Some of the buttons in the measurement mode are used to select which parameter we will change to the buttons. With a route of the user change this parameter, for example, the frequency of the markers on the graph on the frequency bounds of the graph currently paying display. Using the same two arrows buttons, we select which graph the device display. The following graph is possibly by the charts of impedance on the Smith charts. The polar diagram in the same graph on the Smith diagram, but located on the grid, graded in the values of the SVR. Graph of the phase of reflected signal as a function of frequency. Graph of magnitude of reflection coefficient, the model of reflection coefficient on linear scale, and the same graph on logarithmic scale. Next, the most popular graph of SVR, dependence of frequency. Next, in the graph by which you can determine the distance to the point match, you have heterogeneity in the cable loss graph. On each of these graphs, up to 4 multicolored markers can be displayed. The frequency of these markers are set in menu, and while a graph is displayed using two arrows button, you can change the frequency of each marker. Markers, frequency, and measured parameters values and the installation point of these markers and display. All the measurement results can be saved in the device memory. You can save up to 20 results of various measurement and compare a value stored in memory with current readings. It's very convenient to watch happen and what became, for example, when setting up an antenna or other device. In the menu mode, 7 virtual buttons are displayed on the device screen, indicated 7 section of the menu. By clicking on the button, we go to the appropriate section. In the frequency section of the frequency boundaries of the range in which we measure a set. Ether is the center frequency and the frequency band of the start and the end frequency, the number of the scan points, the also set. In the plot section, select the available graphic when switching display modes. You can choose only the most necessary. In the markers section, we set the marker frequency and which parameter the markers will show. Each of the 4 markers can be turned on and off. Calibration is a very important section of the menu. In this section, we calibrated in the device with lots. There are 3 calibrate slots. Open calibration takes place without connected lots. 2 short calibration in the performance with the connection lot with a short circuit. 3 lot calibration with a lot of 15 ohm. These calibration are important for the operation of the device with various adapter cables connector. They do not just calibrate the device, they move the measuring point from the connector port of the device to the end of the connected cable to this device. If you connected a cable to the devices, for example, such as short adapter with a different type of connector at the end, or if you connected a cable 25 meters long from a stationary position to the antenna, you can configure and calibrate this device so that the measurement point is transferred to the end of cable, taking into account of the connector adapter one in the circuit of the cable. This is necessary so that the cable line parameter is not taken into account when analyzer. The parameter of the antenna connected to the end of the cable is very comfortable. If there weren't this mode, the connecting the antenna through the cable, we would see the characteristic of not only the antenna but also the cable and all connectors and adapters. When using a long cable, the data would not be reliable. Calibration can eliminate the influence of the cable and the adapters on measuring the parameter of the antenna itself. Section device contains information about the device serial number, software version. 2 sections with memory cell. The preset section contains up to 30 saved device setting, all the setting, the made frequency range graph. All this can be saved in this version. The traces section store up to 20 measurement results. Each result has its own memory cell. Stored result can be reserved from the memory displayed and compared with the current characteristic of the device connected to the port. How to use this analyzer is described in the detail in the instruction manual. Now I'll tell you about the main feature of the device. In order to calibrate the analyzer, 15 ohm slots, open and close slots are needed. These slots come from a small SMA connector as a larger connector, such N-type or so 2039, depending on which adapter will with the analyzer you will need such lot. Lots are not included in the package, we must be purchased separately. This is how the Smith chart graph, the reflection coefficient modulus graph, the SVR graph in the range from 3 to 40 MHz on the ordinary half-wave dipole antenna with power in the center for 7 MHz look like. The analyzer is now calibrated so that the measurement point is located directly on the analyzer port, excluding the cable. Accordingly, all the graphs are visible given the fact that the antenna connected via cable. The cable used at a good RG58 late 25 meters. The antenna is directly above me. I think that they should have seen the cable on the graph. Now I will calibrate the device based on this cable. To do this, I will have to lower the antenna down, disconnect the cable from it, and connect the load of this end, the cable that connected the antenna. So I lower the antenna, disconnect the cable from it, connect the load to the calibrated the device so that measuring point is the end of this cable. During calibration, of course, the end of the cable alternately remained free, the bridge was connecting to it, the load of 50 ohms was connection to it. Now, with the cable connection with the load, 50 ohms, the Smith diagram look like this. Disconnect the load, the only on cable left diagram look like this. I connected the antenna again instead of the load of the cable, raised it the working height, and the graph on the analyzer now look without cable. This is that CVR chart and Smith chart look like now. Now there are no extra element on these graphs. And this is how the Smith diagram of the dual band VHF. Car antenna connected via RG 2023 cable 20 meters long looks like the instrument was calibrated directly to the instrument's connector. There should also include a cable. According to the should be, it is not possible to understand anything. The graph of the SVR versus frequency in this case look like this. The resonance of antenna is also hardly detected in it. They give me a dual band car antenna, so came into Henry for the experiment. After the calibration was done by connection to the load to the end of the cable instead of the antenna, the graph now look like this. If this graph of the SVR versus frequency is a clear show to resonance, those they do not fall into the emitter band. And this is a graph of the Smith chart. In order to measure the cable length, you need the enter shortening factor of the cable. I enter in the coefficient 0.66 for the cable RG 223, the length of which I will now measure. I connected a piece of the cable to the device. The measured length is 11.6 meters. Often, in the order to determine the antenna and configurator, we use SVR meter. External SVR meter in the form and a separated device connected between the radio station and the antenna and bullet in the SVR meter into the radio station, which, when the radio is transmitting, measure the SVR. Yes, in the way you can determine approximately then the antenna tuned height and low in the frequency. It also quite a convention way. I use it very often. Of course, somewhere in the field on the high in bad weather will not such a device to valid our antenna in configured, but most like we will check it by the SVR meter, build it into the radio station at the best by the external one, and then rather we will take all of it especially on foot. But such a device has many advantages on measuring with the SVR meter. It works autonomously, doesn't not require and radio station work in the high frequency range. The entry VHF band converts up to 6 Hz. It works at microwave frequency. It works independently from his battery. It can be used both indoors and on the roof and measure something. The most important advantage is that in addition to measuring the SVR, which can be used a conventional SVR meter, is allow you to measure various other parameters of the antenna and line. And very important graph is a Smith diagram. On the graph we see not only where this antenna is configured, but its frequency. We see how the active resistance of the antenna changes. All this is clearly visible. Another important advantage of this device is the ability to calibrate it. We can make the measurement point from the connector on this device to the end of the cable, not taking into account the cable and all elements of the line in the measurement of antenna parameters. That's all I wanted to tell you about this Arinst Vector Network Analyzer. Links to the place where you can buy this device, download instruction software, firmware updates to it are in the description for this video. Watch my video and subscribe to my channel. Thanks for attention. Bye.
Здесь был Алексей Игонин. До свидания.